Alright guys, we're still looking at solving oblique triangles, so we're either going to use law of sine or law of cosine, depending on the information that we're given. Thus far we've talked about law of sines, which is sine of A over A, sine of B over B, equal to sine of C over C. Recall that if I have two sides in the angle that's not included, this is the ambiguous case where we have to go through and do the comparisons, determine if we have triangles at all. So we're going to do a couple more examples of law of sines, and then we're going to introduce law of cosines, and I will have practice problems for y'all to do. I'm sorry, I'm not here today. So let's just jump right in and do an example. Kind of a giveaway, law of sines, but I want to solve the triangle given angle B is 38 degrees, side B is 6.4, and side C is 5.9. I've told you we're going to use law of sines, but I still need to know what information is given to determine how I go about actually solving it. So I'm going to start off, draw a picture, and label A, B, so this is angle B. Side B should be across from it. And generally we make the bottom left angle C, so across from it should be side C. So reading what I have a side, side, angle. So I have side, side, angle. This is the ambiguous case. And so I do need to use this sheet to determine first how many triangles I have. So our very first comparison or observation that we need to make is the angle that they give us. This says A, but in our case we have angle B. Is it an acute angle or is it an obtuse angle? Our B value is 38 degrees, which is less than 90, so it is acute. So I'm disregarding the last two cases, I'm just looking at these first four. Notice in the comparisons I used this value h, so I need to know what h is equal to. This says h is equal to b sine of A, but that is if I'm given side AB and angle A. So this is going to change depending on the information that we are given. We're given angle B, side B, and side C. So look how h is going to change. H is going to equal some side times sine of the angle I'm given. In this case, I'm given angle B, so I need to use the other side, not the side that goes or corresponds with angle B, the other side. So in this case, it will be side C for the information that I'm given. So I'm going to start off by finding h, and in this case, h is going to equal C times sine of B, which is going to be approximately or equal 5.9 times sine of 38. I'm going to make sure my calculator is in degrees and plug it in to see what I get. So hopefully you brought your calculator today. So I'm going to go to mode, come down to degrees, whoop, and do 5.9 sine of 38, and I get approximately 3.6. So now coming back to my sheet, making my comparisons. The first one they want me to make is A less than H. Well, this A, again, is dependent on these values. They give me angle A, and they're wanting me to compare side A. So that means the side that corresponds to the angle they gave you. In our case, we're looking at side B. So the first comparison I actually want to make is B less than A. So let's make that comparison. B less than H. My B value, my side B is 6.4. Is it less than H? 3.6. And the answer is no, definitely not. So I'm going to go to the next case. It asks, is A equal to H? Or in our case, is B equal to H? The answer is no. B equal to H. My B value is 6.4. My H value is 3.6. Those are not true, so I don't have this case. I'm going to keep going. Then it asks me just to compare my two sides. Is A greater than or equal to B? A is the side that corresponds to the angle that's given. B is just the other side. So with the information we have, B is the side that corresponds to my angle. C is the other side. So I want to make the comparison. Is B greater than or equal to C. So is B greater than or equal to C? So looking at my information, 6.4 greater than or equal to 5.9. Yes, this is true. So let's look and see what it tells me. Since B is greater than or equal to C, I only have one triangle. So I can go about using law of sines just like normal. So we'll go ahead and set up our law of sines. I have one triangle, so I don't have to do anything crazy or fancy. Just going to set up my law of sines. Looking at the information I have both pieces for B. I have side B and I have angle B, so of course I need to use the ratio with B. And the only other piece of information I have is C, so I need to use the ratio with angle C in it to find that first. So I'm going to start with sine B over B, sine C over C, and plug in my values. So I get sine of 38 divided by 6.4 equals sine of C, we don't know what that is, we're going to find it, divided by 5.9. Cross multiply and divide, I end up sine of C equals 5.9 sine of 38 divided by 6.4. And I don't care what sine of C is, I need to know what C itself is. So anytime I'm trying to find an angle, I need to use the inverse trig function. So that means that C is equal to sine inverse of this whole thing right here. So sine inverse of 5.9 sine of 38 divided by 6.4. And all of that should be in the parentheses for sine inverse. So I'm going to come over here. I like to do it step by step so I don't screw anything up in the calculator. So I'm going to do 5.9 sine of 38. Got that. I'm going to divide it by 6.4 so no mistakes are made. And now I'm going to do second sine inverse of second negative, the answer that I just had. Close my parentheses, and there's my value for C. So C is approximately, I'm going to round to the nearest tenth, so 34.6 degrees. Now that I have two angles, I can go ahead and find the third angle. So I know angle B and I know angle C. So that means that angle A is equal to 180 minus 38 minus 34.6, which is going to be 107.4. So 107.4 degrees. And now the only piece of information that I'm missing is side A. So I know I need to use the ratio that has side A in it, and I know all the pieces of information for B and for C, so I can use either one of those. I started with the ratio with B, so I'm just going to continue using it, but it wouldn't matter if you switched up. So I'm going to do sine B over B equals sine A over A, and we're solving for the side A. So I'm going to plug all the numbers in that I know. So I'll have sine of 38 divided by 6.4 equals sine of 107.4 divided by A. Cross multiply and divide, I get that A is equal to 6.4 sine of 107.4 divided by sine of 38. And this time I'm not looking for an angle, I'm just looking for the side, so I don't need the inverse trig function. So I'm going to come back to my calculator, make sure again that I am in degrees, and I'm going to do 6.4 times sine of 107.4, and I'm going to divide that by sine of 38, and I get 9.9. So A is approximately 9.9. So all of my answers, I'm going to write them out. I know that angle A we found to be 107.4 degrees. Angle B was given at 38 degrees. Angle C we found to be 34.6 degrees. Side A is 9.9. Side B was given at 5.9. And, oh, no, that's not true. side B was given at 6.4, and side C was given at 5.9. Writing them all out kind of helps us to check ourselves. The largest angle should have the largest side value, side length. So 107.4, 9.9. And the smallest should have the smallest. So you can look largest to smallest, largest to smallest. So my answers at least make sense. Okay. So there's an example of law of signs using the ambiguous case. Recall that if you have come up with the case where we have two triangles, you're going to start it off solving just like normal, and then you have to find the other angle. So let's go ahead and do an example of that. So I have angle B, side A and side B. I want to solve, so again I'm going to draw a triangle. Here is angle B, here is side B and side A, and again I have side, side, angle. And so I need to go about figuring out what case I have. This is side, side angle. This is the ambiguous case. So I'm going to start off, I'm going to look at my angle. My angle is acute. So again, I'm looking at these first four possibilities, first four cases, and I need to find what H is. So in this case, I'm going to have H equals the side that does not correspond to my angle times sine of the angle they give me. So every time. So H equals 8.3 times sine of 56.3, which is approximately, where did my calculator go? Oh, I found it. 8.3 sine of 56.3. I get 6.9. And now I need to make my comparisons. So the first comparison, again, this says A, but it's the value that corresponds to the angle I'm given. So the value in my case that corresponds to the angle is going to be B. So the first comparison I want to make is B less than H. My B value is 7.6. My H value is 6.9. 7.6 is not less than 6.9, so I don't have this case, so I'll go to the next. The next case asks, are the two values equal to each other? So it's asking, is B equal to H? B, again, is 7.6, H is 6.9. This is not true. So I'll go to the third case. And it's asking me, is B greater than or equal to A, right? A is the side that corresponds to the given angle. I'm given angle B. So this would be B greater than or equal to A. So is B greater than or equal to A? B is 7.6. A is 8.3. This is definitely not the case. 7.6 is not greater than 8.3. And so most likely it is the fourth case, but we're going to check it legitly just to be sure. So this says H less than A less than B. Again, matched up with the information you're given. It's saying H is less than the side that corresponds to the angle. So we would have H less than, my side that corresponds to the angle given is B, less than the other side. So I have 6.9 less than 7.6 less than 8.3. This is the case. This is a true statement. So I have the case where we have two different triangles, two triangles. When this happens, I'm going to start it off just like regular law of sines. I have all the information for B. I have one piece of information for A, so the ratios I'm going to use are sine of B over B equal to sine of A over A, and I'll be finding angle A, so I need to use the inverse function at the end. So plugging all of my values in, I get sine of 56.3 divided by 7.6 equals sine of A divided by 8.3. Now I'm going to cross multiply divide, and take the inverse. I'm going to do it all in one fell swoop just to save time, but you can do it step by step. So I'm going to get that angle A is equal to sine inverse of 8.3 sine of 56.3 divided by 7.6. Now, whatever I get, let's plug that in real quick. I'm going to do 8.3 sine of 56.3 divided by 7.6. And then I'm going to do the inverse of that answer, and I get 65.3. Now, remember, I have the case where I have two triangles. So what happens at this point after you find, so your very first step is going to be to find that second angle every single time. What you do with the second angle. We have two triangles. I'm going to have triangle 1 and triangle 2. So for my first triangle, I'm going to take the value of that angle we just found. And we know all of our given information still. B is 56.3, side A is 8.3, and side B is 7.6. We just found angle A, and I'm going to call this A1 because it's for my first triangle, is equal to 65.3. I'm going to continue on. I need to find side angle C. So go ahead and find angle C. So this will be C1. And once you find C1, you'll be able to use your law of sines again. To find side C. And that will complete your first triangle. For the second triangle, all of your given information stays the same. You still know angle B is 56.3 degrees, side A is 8.3, and side B is 7.6. Angle A, I'm going to call it A2, for my second triangle, is going to be 180 minus 65.3 degrees, which is going to give me 114.7 degrees. I'm going to do the same exact steps now to solve this second triangle, but using A equals 114.7. And so again, I'm going to find angle C2, and then I'll use my law of sines to figure out what side C is. And then I'll have 6 answers here, and I'll have 6 answers here. So when you come up with the ambiguous case of two triangles, you will have 12 total answers at the end. Okay? All right. That's all for law of sines. Give me just a minute, and we'll look at some law of cosines. All right? And again, I'll see y'all Friday, so if you have questions, just email me. Have a good day, guys. Bye.